Hello again. In the second video of the third chapter, we are going to study some important terms about motion, right? So we are going to begin with the term path length. So what is path length? Well, path length is, as the name says, nothing but the length of the path traveled by the object. In some given time interval. Now you could also call this simply the distance traveled. There's absolutely no problem with that, right? Also, let me mention the symbol that we are going to use for path length. The symbol is D. Okay, we are going to write the path length as D. D generally stands for the distance traveled, right? Okay, so that's the first term. Now, I don't think I have to explain a lot about what is path length, right? I'm sure you will understand that very easily, right? But yet, later on, I'm going to give you an example of what path length is, right? We're going to find out path length, and I'm sure that will make things very clear for you. Before that example, we will discuss about another important term regarding motion, and that term is displacement, right? Now look at the name of this term. The name itself says displacement. Okay, so displace means to shift, right, or change the place. So that exactly is what displacement is. So let me write the official definition. It is change in position of an object. Displacement is the change in position of an object in some given time interval. Okay, right? Now, what about the symbol of displacement? Well, it's a bit interesting how we make the symbol, right? We are going to choose the symbol for displacement very carefully, right? So I want you to understand a few words before we can get to the symbol of displacement. Let's start with change, right? If someone would ask you, what's the change in your mass, in your weight? We call it weight, actually it's mass, don't forget that, right? What's the change in your mass in the last 1 year, right? So let's say that right now your mass is, for example, 55 kg. Okay, but before 1 year, let's say the mass was 53 kg. Okay, you have put on a bit of weight because you have been sitting at home since March. Now, how much is the change in your mass? Well, I'm sure all of you are going to say that the change is actually 2 kg, isn't it? Right? And I'm sure you also understand you got this 2 kg by doing a following, this following calculation. What you did is, right now the mass is 55, alright, but earlier it was 53. So you subtracted 55 minus 53 and got 2 kg as your answer. Well, so this exactly is what change means. Change of any quantity always means final value minus initial value. Initial, that is at start. Final means obviously at the end, right? So change of anything, change of any quantity in physics or in anywhere else actually, change is always the final value minus the initial value, right? So this is something that I want all of you to remember. It's a very important thing, and we are going to use it very often in physics, right? Very important thing, that change means final value minus the initial value. So now let's go back to this definition again. It says change in position, right? Okay, so it's quite clear that what we'll have to do is final value of position minus initial value of position, right? So how do we go about that? So first of all, we are going to define clearly the symbol. Well, symbol for position is x, because we are using x-axis, right? If someone would be using vertical and y-axis, they could write y. There's absolutely no problem again. So here we are going to use symbol for position as x, because we are using x-axis. Okay, right? The symbol for change, right? It's important to express everything in the form of symbols, because we're going to deal with a lot of mathematics, right? Every time you are asked to solve a numerical or a question, it's inconvenient to write big word change, right? So we use a symbol for change, and the symbol for change is this kind of a triangle, right? Okay, this triangle is called delta. You read it as delta. So now if I want to write the symbol of change in position, okay, right, we put the symbol of change in position as delta x, right? Delta again for change and x for position. So delta x together means change in position. But what is this change in position called? Well, change in position is called nothing but displacement. So now if someone will ask you what's the symbol of displacement, I hope you will be able to answer that without hesitation, and the answer is that delta x is the symbol of change in position, right? Okay, so now that we are done with the symbol of displacement, we are going over to an example about motion in straight line, where I am going to clearly specify what is the value of displacement, what is the value of path length. So you will be able to distinguish, you will be able to see the difference between these two quantities, that is the displacement and the path length. So let's take an example where we have made a track. Okay, let's say this is a track. Obviously we are making it a straight line because that's what we are studying right now. Let's say this is the positive x direction and here is the negative x direction. Okay. And obviously somewhere we must have origin, because we are going to treat it like number line. Okay, so this is 0 for O for origin, right? Again, reference point is generally taken over here, right? So that's what we are going to do, right? So what have we done? We have specified a reference point, we have specified the directions as positive and negative, we have chosen our axis, and now we are ready to study motion. But obviously there should be an object to move. So let's say that we have designed a remote controlled robotic ant, right, that can move on this line. Okay, we have designed it so that it can move back and forth on this line. So let's say at start, when you observe, when you start watching, the ant was over here, right, at this point A, which is at 50 meter. Let me just clarify that we are writing everything in meter. At 50 meter from this point origin, or that's 0, right? So 0 to 50, this distance is obviously 50 meters. Right? So at start it was here. So let me just write I over here. Again, I for initial, at start, initial, at start, right? Okay. And we allow the ant, we control the ant, so that ant moves like this, and let's say reaches this point over here. Let's call this point B. Okay. Right? Let's call this point as B. And this point B is suppose 100 meter away from O. So on the number line I'm going to mark it as 100, right? In the number line I'm going to mark it as 100. Okay, so now for this particular case, let's find out what is the path length and what is the displacement. Okay, let's start. So the ant of let me just clarify that here we are talking about the ant going from A to B, right? So the path length when the ant goes from A to B, right? When the ant goes from A to B, what we have is the path length is obviously 50 meters, because I'm sure I don't have to even explain this to you. To walk from 50 to 100, you need to move, you need to walk by 50 meters, right? That's as simple as it could be, right? Now let's talk about displacement. So delta x, right? We should use the habit of we should have the habit of getting symbols everywhere, so that writing or expressing all these things is very simple. So delta x, again delta x stands for displacement. Like I mentioned earlier, we must write final position minus initial position. Again, initial means at start. See, it is so long, I had to write a lot. Okay, I had to write so much, final position minus initial position. That's why, like I said, we prefer to use symbols. So what we do is, position symbol is x, just in case you might have forgotten it, here it is. We use the symbol x for position, right? You must remember all these symbols. So we come back to what we're doing. X is the symbol of position, right? Over here also I should write x again for position, but then there's obviously going to be confusion. Which x is initial position and which x is final position? So what we do is, we write 1 over here, 1 for initial, 1 for the start, right? Okay, x1 stands for initial position, and for the last one we can just write 2. So final is x2, initial position is x1. Again, to clarify, let me just write it over here. X1 stands for initial, that is starting position, okay, and x2 stands for the final position. Alright, so make that very clear in your mind. Okay, these are the symbols that we use for the initial and final position. Now we are going to put these values. Well, let's see. X2 final position. Well, remember we are talking about motion from A to B. We are talking about motion from A to B. So I am sure you realize that A is supposed to be the initial position and B is supposed to be the final position. Correct? Just write F over here. So what this means is, if I want to write the value of x2 over here, I should be writing final position, that is I should be writing position of B, right? Okay, final position for B, that is for B it's 100, right? Isn't it? I'm going to put 100 over here, right? Done. Minus initial position, again that is, now I think it would be easy for you, initial position at A, isn't it? Right? So A was at 50 meter, and that's why I'm going to write 50 over here. So finally what we have is that delta x is 50. But that's not it. There should be a unit. If you would watch the number line that we have drawn earlier, the unit is meter. So delta x is 50 meter. Correct? Right? So over here we have a pleasant surprise. We have it that both are same. Right? But that's not always true. And to specify or to make sure that the difference is clear, let's take another case. Slightly complicated one. Now let's go back to this drawing. Right? Let's say we make the ant start at A, alright, no problem. So the ant moves from A, goes to B, alright, but then doesn't stop over there, just takes reverse, right, moves in the reverse direction and goes all the way, let's say to this point over here, C, right, let's say this point that I've marked over here is C, and this C is at a distance of 100 meter, from O on the left side. And because it is on the left side, I'm not going to write 100, I'm going to write minus 100. Right? So what is happening now is that the ant starts at A, moves to the right side, reaches B, from there takes reverse, that is goes to the left side and reaches C now. Finally, it's at C. Okay, finally it's stopped at C, right? So what we are going to do now is we are going to calculate the same thing. But this time we are going to do it for A to C. Now I have this habit of writing such things. When we start calculations, it's good to write where you are starting and where it's going to end, right? So it starts at A and ends at C, right? Again, what this means is we have started watching the ant from A and we have been watching it till it reaches C. So path length, we are going to have to see the diagram again and again. I could write D. Again, D is the symbol of path length, don't forget. So let's look at the diagram. The ant starts at A, goes to B and reaches C, right? So basically the ant is doing something like this, correct? So how much distance has it traveled? What is its path length? Well, first of all, it goes from A to B, so it will travel 50 meters, right? What I mean to say is going from A to B, it will travel 50 meters, and then from B all the way to C, right? From B it will go all the way to C. So I hope you realize that in traveling B to C, it will have to travel 200 meters because it goes from positive 100 to negative 100, 200 meters, right? So how much total, how much in all did it travel from A to C? Well, the answer is 250, right? Because it traveled 50 meters from A to B and then it traveled 200 meters from B to C. So total path length or total distance traveled is 250 meters, right? Now let's go to displacement. That is where it gets a bit tricky. Delta x. Again, what's the formula of delta x? X2 minus x1, right? Let me just make a box around here. An important formula, you can't afford to forget it, right? It's going to be used very often. So delta x is x2 minus x1, right? X2 stands for final position, x1 for the initial position, right? Now to decide final and initial, this is what helps, right? So let's have a look. A is the initial one and C is the final one. I'm sure you realize that very easily. So let's write the positions. Okay, final position means here I have to write position for C. Let's go to the diagram. Position for C over here, it is minus 100. Okay, minus. Now that minus sign comes from the formula. Now we are going to put the value of x1 over here, right? X1 again stands for initial position, that is the position at A, right? So have a look at A. The position for A is 50, isn't it? Right? This is what you have to read. So now what we have is, let's go on and write 50 over here. So finally I've got that the displacement is minus 150 meters. Okay, the displacement is minus 150 meters. So what this means is that the ant has shifted by minus 150 meters. Right? Now that might sound strange. You can't shift anything by a negative number, right? But here that's what we are getting. So is this wrong? No. The minus sign is not wrong. Okay, it has a very important use, right? The use is that this minus sign is actually indicating the direction of displacement. This minus sign indicates the direction of displacement. Again, to clarify what I mean, you see that finally or ultimately the ant has shifted from A to C, right? Ultimately the ant has shifted from A to C. That is it has been shifted towards the left hand side, right? Compared to where it was initially, was at A initially, right? Compared to that, now it is at C, which is on the left hand side, and the minus sign is indicating that fact, okay, that the ant has been shifted ultimately towards the left hand side compared to A. Now what about the numbers over there? Well, come back to this. What does this number 150 meter indicate? Right? I think that's fairly clear. This number 150 meter is the magnitude of displacement, right? This number 150 meter is the magnitude of displacement. What this means is that the ant has ultimately shifted 150 meter, right? But if you just look at 150 meter and suppose you ignore the sign, right, then the meaning would be different, right? So what I mean to say is that if you write delta x, then writing delta x equal to minus 150 meter includes both information. One, the direction, right? The direction in which the object has been shifted, and second, the distance, the change of the position, right? So compared to where it was, now it has been moved 150 meter, but the question is in which direction? That is answered by the minus sign, right? So obviously here minus sign means left side. I hope you realize why, and that is obviously that is in complete agreement with what we have taken over here. Notice that we have taken that the negative is on the left hand side. So writing minus 150 meter means the object has been shifted left hand side by 150 meter, as you can see over here, right? So this should obviously make it clear once again that displacement is a vector. Why am I saying it is a vector? Because to specify displacement you need this direction, because just saying 150 meter, people might get confused, maybe right side, maybe left side, okay? So when we are specifying when we are specifying a direction, okay, along with the magnitude, right, it's a vector because we need both direction and magnitude for a vector. So displacement is a vector, please don't forget that, okay? Right, now let's talk a little bit about path length, and obviously you can clearly see over here in this case for A to C that path length is 250 meters, but displacement is negative and it is 150 meters negative, right? So obviously they are not same, right? So I hope you will not fall into this common confusion that many students have. Path length simply indicates how much distance the object had to travel. It had to travel 50 to go from A to B, and then to go from B to C it would have to travel 200 more, right? So finally it has traveled 250 meters. Now one more interesting thing about path length is that if I'm going to ask you that the ant traveled 250 meters, in which direction? If you try to answer this question, it traveled 250 meters, in which direction? It's not possible to give a single answer, because I'm sure you very well remember that first the ant traveled towards the right side and then it traveled towards the left side, right? So if you're going to say it traveled 250 meters towards right side, Well, that is wrong. If you are going to say travel 250 meters towards left side, again wrong. So that's why if someone is going to ask you path length is in which direction, there's always a problem, right? Okay, it's not necessary that path length is in a particular direction. You understand what I'm saying, right? It's possible to use your scooter and travel for 100 meter, right? But you could go in any random direction. Okay, you could go on the road and come back, right? So what I mean to say is that path length, with path length, it's not possible to specify direction, right? I'll repeat what I've said. With path length, it's not possible to specify a particular direction. So we say that a path length has no direction, and that's pretty true, right? That is how it should be. On the other hand, displacement will have a direction, right? Either ultimately going from initial to final, the object would either have been shifted right side or have been shifted left side ultimately, right? Again, what you need to understand is that displacement, okay, I'll just write it very clearly at the bottom of this page. Displacement does not depend on the path, right? It only depends on initial and final positions, right? It doesn't depend on how the object moves. What it depends on is just two things: where it starts and where it is finally, right? Initial and final position. So again, these are some very important sentences about these terms, right? So whenever I tell you that this is an important sentence, I will hope that you will make a note of these sentences, right, in your notebook and preserve it somewhere so that you can read all this, right? If you are just going to read these sentences, lots of concepts are going to be absolutely clear, right? So that is what we have about path length and displacement. All right. Okay. Finally, before we end this lecture, I am going to write down a few more key points about path length and displacement. So let's start. Key points about path length and displacement. Like I mentioned earlier, please make a note because these are going to be very important points, right? Number one, path length must be greater than 0 if motion occurs. That is, if motion happens, if something moves, the path length must be greater than 0, right? Because if something moves, it will have a path, it will have to travel some distance. Okay. So the other thing, right, although path length may be, path length has to be greater than 0 if motion occurs, but there's no such rule about displacement, right? That is, displacement may be 0 or it may be negative or it may also be positive, right? For example, the one that we talked about, robotic ant, from A to C, in that case we found that displacement is negative. But when we talked about displacement from A to B, it was positive, right? Because it was towards the right hand side. Again, negative means towards the left hand side, right? Like I mentioned over here, that negative sign is indicating direction, right? if you're going to have a look at the displacement in this case, in A to B case, what you have is that the displacement is positive 50 meter, right? And that means the displacement from A to B was towards the right hand side, as you can clearly see, right? So keep that in mind, that displacement may be negative, may also be positive. Negative and positive are indicating direction. Now what about 0? 0 is when it comes back to the same place. I'm sure you realize that if I'll have a look at the formula of displacement, okay, let's go over here, it's easy for you. If we will look at the formula of displacement, this one, what if initial and final positions are same? That is, object moves somewhere and comes back to the same point A again. I hope you understood what I said. Suppose the object moves somewhere and comes back to the same point A. The final position 50, initial position 50, because both are at A. So 50 minus 50 is going to give you 0, right? So, right? I hope I didn't erase it too quickly. So 50 minus 50 is going to give you 0, right? So this is what happens when object comes back to the same point, right? So in that case, you're going to have displacement as 0. So again, going back to the key points, displacement may be 0 when the object comes back to the same point, or it may be negative or it may be positive, like I mentioned. Right? Now we go to number 3. Right? Path length will generally be greater than or equal to displacement's magnitude. Let me just write it over there. Magnitude of displacement. Okay. The path length is always greater than or equal to magnitude of displacement. Either greater or equal, never less. Right? It's not possible that it's less than the magnitude. Now, that is also fairly simple to understand. If you just have a look at these two examples, you will get a good idea. Like in this one, for A to C, first the object goes towards the right side and then it goes towards the left side. So you see the path length is much more, it's 250 meters. But the magnitude of displacement over here is only 150 meters. Again, magnitude means the value, right? So the value is 150, not minus. Minus is indicating direction. So path length 250 meters, magnitude of displacement only 150 meters. It's less than that. But it could also be equal. Have a look here. In case of A to B, we had path length 50 meter. We had displacement's magnitude also 50 meter. Right? One thing that I notice over here is I didn't specifically write a plus sign, but I am sure you understand that whenever we don't write any sign, we consider it to be positive. For example, when someone writes 3, you're not going to ask that person, is it plus 3 or minus 3? It is obviously plus 3, right? So just like that, when we just write 50 over here in displacement even, what this means is that the displacement is plus 50. Again, plus indicates the right hand side as what we have taken, right? Okay, so the point is that path length and magnitude of displacement is equal, right? The path length and the magnitude of displacement is equal. So you're never going to find that the path length is less than the magnitude. What I mean to say is, it's not possible that path length is less than the magnitude. This way is not going to happen, right? Okay, so keep this in mind. Number 4. If object does not change direction, if object does not change direction, the path length will become equal to magnitude of displacement. And if the object does not change direction, the path length will become equal to magnitude of displacement. Right? Again, never less. Right? It's never possible that path length is less than magnitude. So when does this happen? Like I've written over here, does not change direction. Have a look at A to B case. In A to B case, and continuously moves towards the right hand side, only A to B, right? Don't worry about going from B to C. Okay, so if the ant goes from A to B, the direction doesn't change, it always goes towards the right hand side, and that means that the path length and displacement, they are equal, and I'm sure you can easily see that here, right? Both are 50 meter, right? Magnitude of displacement is also 50, path length is 50. But in case of A to C, I'm sure you remember that first it goes to the right side, then to the left side, the direction changes. So that's why you're not seeing that magnitude of displacement and path length are equal, right? So that is the reason why they're different, right? Magnitude of displacement is 150, but the path length is 250 meters, right? So these are some key points that you should remember. Again, I would say that you note these down very nicely and remember these. Okay, so whenever you have to read these, it's very easy. You don't have to go through the whole book. These concepts are enough, and you will understand the whole chapter, right? So that's it about path length and displacement, and hopefully the examples helped you. We will continue this chapter the next